Hello, everyone. Welcome to Can.Do.So. I'm ready. Today, I'm going to show you the t-distribution and the t-test. And the first, let's note the package we are going to use. First one is tidyverse, and the second one is OpenInter, which will help us to draw the picture. And the third one is Gapminder, which we will use this data as an example to do the t-distribution t-test. Let's get started. So t-distribution is also called student's distribution. So it's a very similar to normal distribution. So here's a question. Why we need t-distribution since we already have normal distribution? Because we don't know the standard deviation of the population and the sample size is very small. So we can't use the normal distribution to do the test. So generally, the t-distribution is a family of distribution that looks similar to the normal distribution, but have heavier tails, which has a, I'll show you the plot, t-distribution plot later. This t-distribution is used for inference on the mean when the population standard deviation is unknown. And the t-distribution is centered at 0 and has a parameter called degrees of freedom. So if the degrees of freedom is different, and the t-distribution will change slightly, and the degrees of freedom is equal to the sample size minus 1. And as the degrees of freedom increases, the t-distribution approaches a normal distribution. So let's take a look at the t-distribution and compare with the first three is t-distribution with degrees of 5, 3, and 30. And the normal distribution is so we can see this two is with 3 and 2. This is with degrees of 5, and this is degrees of 3, and this is the degrees of 30. You see that if sample size is 30, it's very close to the normal distribution, because this one is the red one is normal distribution, and the purple one is t-distribution with same degrees of freedom with 30. So you see the t-distribution has a lower peak. This is lower than this normal distribution, and the heavier tail it's higher than the normal distribution. So the normal distribution is goes like this, and the t-distribution will here in the tail it higher or heavier, and in the peak is lower than the normal distribution. Okay. So as the long tail of the t-distribution, the t-distribution has the more probability in the tails. So in the tail has a more this probability because the area under the curve is bigger. So to cover the same area under the curve, the t-distribution has a wider spread than the normal distribution. So because the normal distribution is more centered in the middle, and t-distribution is a little spread outside. So to cover the same area under the curve, the t-distribution has a wider spread than the normal distribution. And so we need to use a larger critical value for the t-distribution than the normal distribution. Here we can compare the formula to calculate the confidence interval of the mean of normal distribution and t-distribution. This one is uh, this one is okay. So this is normal distributions confidence interval, and this is t-distribution confidence interval. You see here, normal distribution has no degrees of freedom, but t-distribution has degree of freedom, which is n-1. And both is, if this is a two-sided, so it's divided by 2. Alpha is the critical value. So the one sample t-test is used to compare the mean of a single. Okay, first we see the one sample t-test. The one sample t-test is used to compare the mean of a single sample to a known value or any value we choose to test. So one sample t-test is, which means we have a sample and we want to test the sample's mean if it's equal to a with whatever value we want to choose, we want to test. For example, if we knew the population mean is mu, then we can test the samples mean if equals to the if the samples mean equals to the population's mean. And if we don't know the population mean, maybe we can test the sample mean to a specific value. For example, we might want to know if the average height of a group of people is equal to 170 centimeters or not. So the null hypothesis is that the mean is equal to 170. And the alternative sub-hypothesis is that the mean is not equal to 170. So the test statistics is calculated as this. So this is the statistics. Here is a mean, sample mean, and this one is the value we want to test. For example, in this case, we want to test is equals to 170. And S is the sample standard deviation, and N is the sample size. So this two is equal to standard error. So the test statistics follows a t-distribution with n-1 degrees of freedom. So let's go to the R to see the, yeah, we use this Gapminder, which looks like this. With country and continent, year from 1952 to 2007, and life expectancy, and the population, and the GDP per capita. Let's take do the test. Take the life expectancy as example to do the one sample t-test. So here we first filter the year. We choose only 2007 and use t-test, use this t-test function and the life expectancy. Delta 1, which means one sample, and mu is 70, which here we want to test if the all countries life expectancy is equal to 70 in 2007. So let's see. So the outcome will tell us this is one sample t-test. So the statistics value is minus 2.9, which is pretty high. So the t is pretty high, so which means p-value is pretty small. So we can see that in this case, if this one is the bigger is the absolute value is larger, so the error will be smaller. So this one is the outcome is quite big, so the p-value is quite small. It's much less than the 1% significant level. Here we choose 5% significant level. So in this case, we reject the null hypothesis and conclude that the average life expectancy in 2007 is not equal to 70 years old. Actually, is 67, and the 95% confidence interval is between 65 to 69, which does not cover 70 years old. So we reject the hypothesis. Okay, that is one sample t-test. Let's take a look at the two sample t-test. The two sample t-test is used to compare the means of two independent samples. And the formula for the test is like this. Here, x1 is a group 1's sample mean, and x2 is group 2's sample mean, and s1 is group 1's standard deviation, and s2 is group 2's standard deviation. So in R, we can, here we use the same gap and filter the year and choose continent with Asia and Africa. So we can take a look at it. So we have two continents, yes, Asia and Africa. And in both in the 2007 years and the life expectancy. So we compare the two continents, Asia and Africa. This tells us it's a Welch two sample t-test, and t is much larger than just now. So the degrees freedom is 77, and the p-value is 2.9, and to the power of minus 12. So it's close to 0. So in this case, we also reject the null hypothesis. The null hypothesis is which means the two Africa and Asia's life expectancy is not statistically significant different. But so we reject it, which means they are significantly different. We can see that Asia is pretty high, 70, and Africa is 54. It's 16 years difference. So we reject. I forgot to mention that this data equals to this one, which means we use data we created by this step. Okay, let's last week take a look at the paired t-test. The paired t-test is used to compare the means of two dependent samples. It usually used in situations where the same sample is measured in different times or conditions. For the same group, for example, we choose a country like uh, here. We choose all the country, and we compare the life expectancy in 1952 and 2007. So in 1952 and 2007, which are the same group, the countries in 1952 and in 2007 is the same. So they are compared to themselves, but in different times. One is 1952 and the other is 2007. And in other cases, normally we will use this paired t-test in medicine test. So one might use a medicine one. Uh, no, what the group one will be without the same group uh, haven't take the medicine, and we compare it to maybe 1 year later. They have taken the medicine a year, and 1 year later we compare the two group. We compare the same group before and after the 1 year medicine treatment, and we test if there has some significant effect of this medicine. So here the formula is TXD, which means group. The second the the second stage minus the first stage, and this one is also the difference standard deviation, and n is the sample size. So we take a look the R code. First, we filter the year 1952 and 2007, and we do the test compared to year, which means we pair these 2 years. And here we will add an argument paired equals to true, which means we use paired. So it will tell us it's a paired t-test, and the t value is pretty high, and the p value is pretty low. I mean the absolute value is pretty high. It's pretty far away from zero. So since this is p value is pretty small, so we should reject the p value. We should reject the null hypothesis, which means the life expectancy in 2007 is not equal to 1952. Definitely not. And this is equivalent to the following one sample t-test. Actually, to help you understand the paired t-test, we can take a look the step by step. First, we choose only 1952 and 2007, and then we select year and life expectancy, and we will compare this year to this year for all countries. So we spread the long table to wide table, long to wide table. We use spread function, Notice that here is 284, so paired countries, and okay, now it's halved to 142 countries, and so one country is one row, one is 1952, and one is 2007, and this is his the Afghanistan life expectancy. Okay, we can take a look at it. So this one, each row is a different country, but if we didn't spread, so each country has two rows. You see the difference? Okay, now we use this one minus this one, mutate. So we create a new variable. No. So this one is 2007 minus 1952. We got this a new variable. Then we take one sample t-test to this one, and you see you will get exactly the same number with this one. Here is the sign is different because in here we use 1952 to minus 2007, and here we use 2007 minus 1952. So the sign here should be minus, and here should be minus. Here this also should be minus, but the p-value is the same. You see, p-value is the same, so it's pretty it's the same because the p-value is pretty small. So we should reject the how null hypothesis. So here, if we omit the paired equals to true argument, we will get a two sample t-test, which means we compare the life expectancy in 2007 with the life expectancy in 1952 for a different group of countries. Actually, it's the same, but we assume it's different. So if we can also, here we don't use the paired equals to two. Here we, yeah. So the degree of freedom is 197. And the outcome is different. You see, TYO is different, and this is different, this is different. Although we still reject the hypothesis. So notice the difference of degrees of freedom, because this is degrees of freedom 197, and here is degrees of freedom is 141. And also notice that two groups of countries should be paired if we do the paired t-test, which means the countries in the two groups should be the same length. Here I intentionally omit the countries in Africa in 1952 to make the two groups of countries not the same length. So I reduced the delete the countries in Africa. So the two groups in 2007 and 1952 are different. So you see in 1952 there's no Africa. Africa only has 2007. So which means the two groups are not in the same length. So if not in the same length, we paired equals to true will give us an error message. Not all arguments have the same length. So that's why paired has to be paired, one paired one, so they have to be, has the same same length. You might ask if in our sample and in 1952 has some maybe missing numbers, but in 2007 in this country we have the values. So in that case, the R will automatically to delete the missing values in pair. So if one country in 1952 has missing values, the R will delete both values in 1952 and 2007. So as to make the length the same. Okay, that's all for today's course. So and so in this student we learned one sample t-test, two sample t-test, and pair t-test and t-distribution. So however, the t-test can only compare the means of two groups, which means what if we want to compare three groups, for example, three continents. Just now we just compared Asia, Africa. What if we want to compare Asia, Africa, and Europe even more? Or what if we want to compare a uh, paired t-test with 1952, 1970, and 2007? The t-test cannot do that. We have to use ANOVA test, which will be covered in the next lessons. Okay, that's all. And if you have, as usual, if you have any questions or suggestions, please leave a message below, and I will respond to you as soon as possible. Also, if you like this, please like it, uh, share it, and subscribe my channel so I can make this channel better. Okay, thank you. See you next time.